Hello, today I'm going to take you through my introduction to quadratics, more specifically the equations to them. So let's jump over and see the actual example I have for you to start off with. I treat this kind of like a discovery type of problem where you're going to go through and do these directions here on all four of these problems. And from that, I hope that you understand a little bit more about the equations of quadratics. I could just go through and say, here's the equation of a quadratic, and these are, this is where the vertex is. This is how you find the x-intercepts. This is how you find the y-intercept. This is how you know if it opens up or down. But I want you to kind of discover that, because I think if you understand through discovery, it will make it easier to remember in the future. And I always believe that if I can show you why the math works the way it does, it's much better than just saying, here's the formula and here's how you graph it and get to it. So let's go back to that problem right there. And it says that it wants us to graph x minus 2 squared minus 1. Well, it's kind of hard, I think, in the video maybe for you to see that graph. So I'm going to use this graph right here, and we want x minus 2 squared minus 1. X minus 2 quantity squared minus 1. That's what we're graphing. And remember what we're doing with this. We're taking our typical parent function of x squared, and we're going to be shifting it around when we look at this right here. So this minus 2 is going to tell me to shift right 2. And then that minus 1 tells me to go down 1. Remember, it's on the outside. If you don't remember that, go back and look at my video on the transformations of parent functions, because we cover all of that in there. So typically, the parent function x squared has a vertex right here at 0, 0. But all the points are being shifted right 2 and then down 1. So that vertex goes to the right 2 and down 1. And from there, it's basically like there's no stretch or compression vertically to this thing. So it's like I'm going to take this thing and just graph it right here as if that were the origin. So if I go over 1, I go up 1. Go over another 1 and go up 3. Go over another 1 and up 5. It's here 2, 3, 4, 5 right there. And then it's going to be symmetrical from this line of x equals 2 right here. So I'm going to go over 1 here. Oh, it went over 2 that way, go over 2 this way, and then 3 from this line of symmetry. I'm going to go ahead and graph this line of symmetry now, because it will make it easier just to make sure that I'm being symmetrical. So there's my line of symmetry slicing right through that vertex, and now it's easier to make sure that I counted over correctly. So over to the 1 to the right, 1 to the left here, 2 to the right, 2 to the left, and then 3 to the right. So I'm going to go 3 to the left right there. And now I can draw my parabola. All right. So that's the first one there, okay? Now let's go back and see what else it said for us to do here. It said to use a dashed line to draw the axis of symmetry. We got that taken care of. And then it says to prove that x minus 2 squared minus 1 is equal to x squared minus 4x plus 3. And it kind of tells you exactly how you want to prove that. Work out the left side so that it equals the right side. So let's do that next. So I'm going to take x minus 2 quantity squared minus 1. And I'm going to show that it equals this by working this out. So remember, with our binomials squared, we can do our little trick where we square the first term, square the last term, multiply the two, and double them. So that is what this right here is equal to, this trinomial. And then don't forget, we need to bring down that minus 1. And so that gives me x squared minus 4x plus 3, which is what we were trying to show that it equaled. Okay? So I'm going to leave this down as number 1, just in case we need to come back and reference it. Now, it says to use the quadratic formula to find the roots, or zeros, you can call them. And it says simplify it so that it's some number plus or minus another number. For example, your answer should look like something 7 plus or minus 5. So if you don't remember the quadratic formula, remember it is negative b plus or minus the square root of b squared minus 4ac all over 2a, right? And so when we have this right here, x squared minus 4x plus 3, remember that on this, the coefficients are what I'm looking at. The coefficient right here is a 1. That's going to stand for my a. Negative 4 is my b. And positive 3 is my c. And I'm going to substitute it into this equation right here. So substituting that in, a negative b is going to become negative 4 plus or minus the square root of negative 4 squared minus 4 times a. Well, a is just 1 times c, which is going to be 12. And this is all going to be over 2 times a. So negative 4 becomes plus 4. Negative 4 squared is going to be 16. And then 16 minus 12 is 4. So I get this mess right here. Simplifies to just 4. I have my plus or minus there. This becomes positive 4, and it's all over 2. Now remember, this is a fraction. And I've got a fraction with a plus or minus in front of it. Let's go ahead and simplify it a little bit further. This can become, 2, right? So I've got 4 plus 2 and 4 minus 2. I'm going to split that up into two different answers here. So I could have 4 plus 2, which is 6 over 2. And then I have 4 minus 2, which is 2 over 2. And so we get our zeros to be 3 and 1. And that should make sense because let's go back and look at our graph. And notice on our graph, we are crossing at 1 and we are crossing at 3. And that's what the quadratic formula helps us do. It helps us find those zeros and roots of a quadratic. Now, the actual directions, though, said to leave our answer in the form of this 7 plus or minus 5. It should look something like that. I didn't want to give you the answer, so I didn't tell you what the answer was there. So we need to kind of backtrack some so we make sure that we write the answer in the correct form. Now remember, this is a discovery activity, so typically I don't have you write it like this. I'm getting at something here, so hang with me here, and let's just go ahead and do what the directions say. So go back to this 4 plus or minus 2 over 2, and I can split this up. This is a fraction, all right? Just like when I have something like, say if I had x plus 2 over 4, I could split this up into x over 4 plus 2 over 4, right? Because remember, when we add fractions, if they have a common denominator, we can add the numerators and put it over that common denominator. And so this is the same thing as x plus 4 plus 1/2, right? Well, that's what I want to do here. I have 4 plus 2 over 2. So I'm going to split that up into 4 over 2 plus 2 over 2. And that becomes 2 plus 1. And then I've got 4 minus 2 over 2. So I'm going to split that into 4 over 2 minus 2 over 2. And it becomes 2 minus 1. So the direction said to leave it into something like 7 plus or minus 5. This is going to be 2 plus or minus 1. That's how I want to leave that answer for that one. Okay? There is a reason. Now you're saying, like, this is weird. Remember, we're doing a discovery activity here. So we're going to figure out a pattern is what we're going to end up looking for. Go ahead and try out the next one. Now the next one, number 2, says to graph x plus 1 quantity squared minus 4. So that's what we're going to do next. So we're going to graph x plus 1 quantity squared minus 4. Once again, our parent function is x squared here. And so we want to use our transformations to easily graph this. The plus 1 tells me to shift it to the left 1. And then the minus 4 tells me to shift it down 4. So I'm going to pretend like that's my origin. In fact, I'm going to go ahead and graph my axis of symmetry. So that way it's easier to graph as I try to use symmetry. And so we're going to go over 1, up 1, over 1, up 3, over 1, up 5. 1, 2, 3, 4, 5. Put a dot there. And then I can use that axis of symmetry to help me use graph the left side using symmetry. So I'm going to go over 1, over 2, 1, 2, over 3, 1, 2, 3. Now it's not as easy when we have a number in front of that parentheses there that's going to be stretching it vertically or compressing it vertically, but if a is equal to 1 in that equation, it makes it nice and easy for us. All right, so that's our first step. We've got it graphed. The second step says to use a dashed line to show us our axis of symmetry. Got that on there, and now we want to do that whole thing where we prove that this is equal to that right there. So let's go ahead and do that. Our equation is x plus 1 quantity squared minus 4. And then x plus 1 squared, well, let's do our shortcut. We get x squared. We get 1 squared is 1. Multiply the two, double it. There's our trinomial. So remember, that's this mess right here becomes that trinomial. And then next, I'm going to bring down that minus 4. Combine my like terms. I get a minus 3 when I combine those two. And so I get x squared plus 2x minus 3. Let's check it. That's what I said I wanted to equal to. Okay? So that works. And now the next step is to use that quadratic formula again. I'm just going to write this down in case we need to reference it. This is number 2 here. And so once again, with the quadratic formula, we want to identify that this is my A, 1 is. This is B. And then negative 3 this time is going to be our C. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. 2 goes in for negative b. We get negative 2 plus or minus the square roots. Well, b squared in this case is 4 minus 4 times 1 times negative 3. So 4 times negative 3 is negative 12. And then the minus and negative becomes plus a positive. All of this goes over 2 times 1, which is 2. And now let's simplify this a little bit further. 4 plus 12 is 16, and the square root of 16 is 4, so I end up with negative 2 plus or minus the square root of, let's see here, 16. Or I already said 4, but we can do that on the next step. And now I'm going to divide this fraction up here into 2 spots. I'm going to say it's the same thing as saying negative 2 over 2 plus or minus 4 over 2. So this becomes negative 1 plus or minus 2. And that's what I said in the directions I want there. Negative 1 plus or minus 2. And of course, if we take negative 1 and we add 2 to it, we get what? 1. And if we took negative 2 and subtracted 2 from it, we would get negative 3. Notice those are our roots, 1 and negative 3 from our graph. 1, negative 3. So as we do this, we can see that we are easily coming up with these roots. Remember, these won't be so easy to graph all the time, or maybe we don't want to graph it. Maybe we just want to look at the equation and say, boom, there's your roots, there's your vertex. We know which way it's pointing up or down, that sort of thing. So we're working towards our discovery here in these upcoming questions. All right, let's look at number 3. So number 3 says to graph x minus 4's quantity squared minus 9. Now, I don't know if my graph here that I've got set up, these graphs I can't do minus 9 on the outside, so I will use this one right here. You'll have to do it on your own. You might be able to see that. I don't know, depending on whether you're watching on a computer or on a phone. But this tells me to go right 4, and this part says go down 9. And that's why I got to use this one with smaller blocks on it. So right 4, there I am, down 9. So there we are. And I'm going to go ahead and draw our axis of symmetry. And as you do this for me, please always use a ruler. If you're drawing it on a test or a quiz, even if you don't have a ruler, you can fold a piece of paper, a scrap piece of paper, and that will give you a nice straight edge. We always want to draw our straight, our lines here with some type of straight edge, so it looks nice, neat, and professional. All right, so let's go ahead and graph this thing. Go over 1 up 1, over 1 up 3, over 1 up 5, 1, 2, 3, 4, 5. Over 1 up 7 should be next. 1, 2, 3, 4, 5, 6, 7. And then we're going to use symmetry here. 1, 2, 3. 1, 2, 3, 4. Isn't it fun just graphing parabolas? It's like artwork, unless you miss the point right there. No pun intended. All right. There's our graph, and now we're going to do this whole proving thing. So let's go ahead and do that right here. So I want to prove that x minus 4 squared minus 9 equals that mess on the right. So I'm going to square the first term, square the last term, multiply the two and double them. I get minus 8x. So that is, this binomial squared gives me x squared minus 8x. If you can't see it, that's a, here, let me write it out larger. X squared minus 8x plus 16. And then don't forget, we got to put that minus 9 in here. And then 16 minus 9 is 7. So I get x squared minus 8x plus 7. Oh, look at that. That's what I wanted to show that it equaled. And next, we're going to go to the quadratic formula. And because I write so large, I don't think I'm going to be able to put it into that space there. So I'm going to identify my A, B, and my C. My A is equal to 1. The B is negative 8. And then the C is going to be 7. So quadratic formula, remember, negative B. Well, a negative 8 becomes a positive 8. Plus or minus the square root of B squared. Negative 8 squared is 64. Minus 4 times A times C. Well, 4 times 7 is 28. And this is all over 2 times A, which is just going to be 2. All right. Now, I need to do 64 minus 28. Well, 64 minus 28, let's see. If you can't do it in your head, I like to pick a point in between, like 30, and say, well, the top is 34 away from 30. The bottom number is 2 away from 30. Add those 2 up, you get 36. You could subtract it old school way. Whatever works for you. So that becomes 36. So I've got 8 plus or minus the square root of 36 over 2. Square root of 36 is 6. So I get 8 plus or minus 6 over 2. And then I'm going to split this up into 8 over 2 plus or minus 6 over 2. So I get 4 plus or minus 3. That's what I want written right here. 4 plus or minus 3. If I wanted to find the zeros of my function here, I could say 4 plus 3 is 7, and 4 minus 3 is, it's 1, right? Sorry. Sometimes I pause because I'm thinking about what I'm going to say next. So I got 7 and 1 here. So let's see if we got this right. If you look, it's kind of hard to see, but right here, right in here, let's say, if you can't see it, that's our y-axis. So it is crossing right here at 1, and then this number right here is 6, and then that is 7. So it is, in fact, crossing at 7 and 1, which is what we wanted. But more importantly, we want to see these numbers and see how they relate to the graph. So now's the time to go back and look at these. Look at your graphs. I don't have the graphs here. They're over here. And so for number 1, it says that we've got 2 plus or minus 1. And then for number 2, we've got negative 1 plus or minus 2. And then, of course, for the one we just did, we got 4 plus or minus 3 right there. I want you to look at the graphs, pause the video, look at the graphs, and see where is this first number represented on the graph, and where is this plus or minus 1 on the graph. Here's our graph number 1. where do we have 2 represented? And where's this plus or minus 1 represented? All right. I've trusted that you've paused the video and you're ready to give me your answer. So this 2, notice, well, first think about it like this. We come up with our zeros by saying 2 plus 1 and 2 minus 1, right? So look directly down to where our zeros are. And notice that we are a distance of 1 away from our axis of symmetry on this 0. Whether it be to the right or whether it be to the left, the distance there on both sides is 1. That's where that plus 1 is. Plus 1 meaning go to the right one, and then the minus 1 meaning going to the left one. What are we adding or subtracting that 1 to? The number 2 here, right? And in this case, notice it's our axis of symmetry is located at x equals 2. That's the equation for the axis of symmetry on that parabola. And then the plus or minus 1 sends us to the right or the left. Look at the next one. Now the next one we said -1 plus or minus 2. And notice what we've got going on here. We're going 2 to the right, that's our plus 2. And then we are going 2 to the left, that is our minus 2. So this plus or minus tells us the distance that we are on either end from the axis of symmetry. Notice the equation for axis of symmetry is -1 here. So x equals -1 is our axis of symmetry. By the way, on your homework, quiz, test, whatever, if you're in my class and I ask you for the axis of symmetry, I want an equation. Don't tell me -1. I don't know if you're talking about y equals -1 or x equals -1 or just a random number -1. I want the equation of a vertical line. So it should be x equals a number, okay? If you don't, you're going to get some points taken off. So please write out x equals whatever that equation is. So x equals 2 for the first one, x equals -1 for the second one. What about this third one right here? So here's our graph, and we've got 4 plus or minus 3. Without even looking at the graph, you should be able to tell me, hey, the axis of symmetry is x equals 4. And then this plus or minus 3 says, if I were to just draw it out, the axis of symmetry, let's do that now. So if I were drawing this thing out brand new, and I draw out the axis of symmetry at +4, let's grab our ruler. 1, 2, 3, 4. Then I know that the zeros are going to be coming through this thing at, let's see, 3 to the right and 3 to the left of it. 3 to the right, boom, 0. 3 to the left, boom, a 0. And this thing is going to be swooping in like this, all right? And for this case, remember that our vertex was at -9. So, what was I going to say? It's off the graph, all right? Now, let's look at the equation. If I take this equation right here, the quadratic formula, I can split it up from the get-go. Notice on the last problem, this is what we had when we put it into the quadratic equation, right? I could take and say, this part right here is 1 fraction. So I get 8 over 2 plus or minus this other part right here, which would give me the square root, or you could break it up right here, the square root of 36 over 2. And this would all simplify to 4 plus or minus the square root of 3. So from the get-go, we can actually split up the quadratic equation if we want. And that's what I'm going to do right here. I'm going to say, you know what? I've got -b over 2a. Let's write that out on one side. And then on the other side, I'm going to have the square root of b squared minus 4ac all over 2a. Square root b squared minus 4ac all over 2a. And so remember what happened with this last equation, just because I know that sometimes these variables stuck in here confuse students because you're like, okay, this is starting to look more and more abstract. So go back to this. This is the one side, this is the other side when we split up those two fractions. And it simplified down to 4 plus or minus 3. So if you take this right here, this becomes 4 plus or minus this square root of 36 is 6. 6 over 2 is 3. This was our axis of symmetry, right? X equaled 4. That's our axis of symmetry. And then this right here was our distance from the axis of symmetry where our zeros were. I'm not going to write that out, but that's what it stood for. So when I'm looking at this right here, I just split this up from the get-go. Whatever this is our axis of symmetry. X equals negative b over 2a. Keep that in mind. We're going to use it a whole bunch, okay? So our axis of symmetry. And then the other part right here, all of this mess, b squared minus 4ac all over 2a, this becomes our distance that zeros are from the axis of symmetry. So another way to say that is you could say how far right or left you go from the axis of symmetry until you crash into the zeros. All right. So that's what we're using quadratic formula for here, or that's another way to look at the quadratic formula. You might have recall from your other classes, or maybe even one of the classes you're in with me, if you had me for Algebra 2, you might have recalled that, hey, the quadratic formula tells me where the zeros are, and specifically it helps me when I can't factor something. I can throw it in the quadratic formula and it will tell me exactly where the zeros are. But it also helps us when it comes to graphing these things because it tells me where the axis of symmetry is. Now, one thing to keep in mind when we look at these graphs, let's go back and look at one of our graphs here. Where did I put it? So going back to this one right here, once you know that the axis of symmetry is x equals 2, the vertex must be on the axis of symmetry. Notice our vertex is right there at -2, -1. Over here, axis of symmetry, x equals -1. The vertex must be on the axis of symmetry. And look, -1, what was it? -4. And so not only does negative b over 2a tell us the equation for the axis of symmetry, it also tells us the x value for the vertex, okay? So it helps us figure out where that x value for the vertex is. It tells us where the axis of symmetry is, okay? Those are two important things. In the next lesson, we're going to figure out how to find out this y value. And so we're on our way to graphing without using those baby methods where we just say, let's make an X chart, let's make a Y chart. Those are okay. Those are beginner steps. But now we're deepening our knowledge of using the equation. And hopefully, after today's lesson, you understand a little bit more about the quadratic equation, how we can split that quadratic equation up, come up with the axis of symmetry, and then find the x value in our vertex, and also, of course, find out where the zeros of the function are, where are they crossing the x-axis or the x-intercepts, okay? I hope this lesson proved useful to you. You're going to try out some practice problems. Please ask me questions. I love answering questions from students, and I'll see you next time.